Hello, welcome to another presentation of materials for industry. Today we are focused on neodymium, a rare earth element. Neodymium, the word in Greek means new twin, derived from neos, new, and didymos, twin. It is a chemical element with symbol Nd and atomic number 60, belonging to the series of rare earth metals. It was discovered in 1885 by an Austrian chemist named Carl von Welsbach. This metal is a silvery white, hard, and slight malleable metal that tarnishes quickly in air. It can be used in coloring glass and ceramics. It has strong paramagnetic properties, making it a key component in neodymium iron boron. Magnets widely used in electric motors, headphones, electronics. Neodymium is found in minerals such as monazite and bastnasite, which are widely distributed in the Earth's crust, though it's usually extracted and purified for industrial use, such as in high-strength permanent magnets for electronic devices, glass dyes and coloring agents for optical applications, lasers for medical and cosmetic procedures, and spectrometry calibration due to its sharp light absorption bands. This presentation will primarily focus on the extraction, purification, and uses of neodymium as one of the strongest magnets. Extraction and mining. Open pit is the most common method for surface deposits. Involve basically removing the overburden from the surface and to access the ore through excavation. Underground mining is used for deep deposit, involving creation of tunnels and shafts. And ion adsorption clay leaching is a low-impact method used in some deposits, especially in China. Here's a sample of bastnasite ore and monazite ore. Neodymium, after processing, it is extracted through a multi-stage physical separation and chemical separation. A multi-stage that takes many steps and which is highly constrained by its chemistry, separation, and finishing capacity. Here's a simple overview of the process. When the ore is mined, transported, crushed, grinded, and separated in a multi-stage process on which eventually it'll become a powder that is separated and further processed into the material. Separation of neodymium. The technology has evolved on which solvent extraction and liquid chromatography are used for the separation of the material. A liquid extraction is where rare earths are selectively and sequentially loaded into organic solvents, separated, and then recovered into aqueous phase in a multi-step process. Liquid chromatography, where dissolved rare earths are separated into discrete fractions based on different interactions with the stationary phase, in general like silica or ion exchange resins. The strength in solvent extraction is that it's a more mature and scalable technology, and high volume and throughput in higher purity products. In liquid chromatography, the feedstock is agnostic, modular equipment set up for a small footprint, and a quick process in a batch. Magnetization is a process where the metal alloy is subject to a magnetic field to make it a permanent magnet. Neodymium with iron and boron, it's an alloy that once it's melted together, they are not magnetized per se. But once they go to a final process in magnetization, which makes a permanent magnet, then it becomes a strong magnet. Here are some of the examples of the magnets created with neodymium and some of the uses that are widely used in industry today, on which the power of the magnet and the size of the magnet are the key components that make these materials so special and widely used in the industry. Thank you for listening to this presentation. I appreciate the information provided, and here's the references that we are using for this presentation. Thank you. Have a great day.